Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Musharrafah binti Karudisham and my group member is Wan Siti Zulaika binti Wan Muhammad Zulkifli, Nur Alisha Shazrin binti Irwan, Aiman Nafis bin Muhammad bin Abdul Razak, and the last one is Muhammad Zahari bin Nazar Muhammad Zarizi. We are from group 2 and I will explain about lab5, which is heat exchanger. We start with introduction. Water in use in the SE134 heat exchanger control churners process. This churner was created to conduct process control experiment. This churner generates shell and tube heat exchanger product temperature that can be controlled by the microprocessor-based controller. Hot water in this lab was being determined in the system by the hot water calculation pump, passed through the tube side of the heat exchanger and returned to the hot water tank. And then cool water is distributed from the cool water tank through the shell side by cool water calculation pump, and then the heat product can be cooled down by the operational air cooler radiator. Now we go to the problem statement. For this lab, the problem statement is the majority of manufacturing use authentic heat transfer fluids such as water in heat exchanger in their cooling system. Thus, by using base fluid as the heat transfer fluid, the rate of the heat transfer can be increased while the heat exchanger pumping power is reduced. Now we go to the reference. We have three references from this lab, which is Solution Engineering Sdn Bhd, UPUCOM, and Agency F. That's all for the reference. And then we go to the simulation result. This is actually the simulation result for the PB100, PB50, PB100 and I is 300, PB100 and I is 120, PB is 100 and I is 60 seconds, and then PB is 100 and I is also 60 seconds. We also have been changed their D, which is for the first is for 0 second, and then we change to the 6 second, and then we have been changed there for the 3 second. This is the result from the machine. So for the conclusion, the heat exchanger is a device designed to efficiently transfer heat transfer from one medium to another. The heat exchanger process control churning system was designed to demonstrate and given student practical churning experiment which controlling a temperature loop for the heat exchanger using a microprocessor-based controller. The experiment began with the setup procedure. We set PB and D to 100 and 0 for proportional and integral heat exchanger control respectively. Next, we have changed the value of R to 120 and 20. Then, we change the value of T between 60 seconds to 300 seconds for the PID heat exchanger control while keeping the value of PB and the D is constant. By varying the set power point and introducing a system distribution, 3 sets of tuning parameters were tested. Lastly, when they compare to other methods, the obtained response curves are less circular and more stable. This demonstrates that PID is the best choice for saving time and being the most efficient. That's all from me. Thank you.